any place where something valuable is kept is called a reservoir. But for us subsurface engineers and scientists, it's a three-dimensional body of rock where hydrocarbon are located. It could be sand, it could be carbonates. In some cases, you also find it in fractured basement rock, surprisingly. But yes, those are unconventional reservoirs. But dominantly, when I say reservoirs, I'm speaking to clastics, which means sand in this case, dominantly sand, because that's what we are more familiar with in this part of the world. So they begin their journey from a parent rock. These reservoirs, in terms of formation, they start from somewhere, and through time, they get, transformed to a form where they are finally deposited, and then oil can find its way and get stored in them. And I'm going to show you, I was going to say that for this talk, we're talking more on plastics, which is our focus of this for this presentation. So these are surface occurrences of reservoirs. So you go on, what we do as geoscientists, we go out there to study rocks. A bunch of people look at us as bushmen or people that are probably a little crazy, just standing around looking at rocks. But that's the beauty of it. We need to understand what we see on the surface to give us a better picture. Yes, thanks, Shay, for that. So we need to understand what we see on the surface or at the surface to better understand what is buried thousands of feet below. Okay, so we understand, we see it here, we draw a model, and then it gives us a better picture of how to relate to the ones that we don't see, that we only see when we drill a well. And then this is also another example from my archives, taken from here in our own Anambra Basin in Southeast. So these are classic examples. Sandy, oil will find this place a very fun place to be because it's got the pore spaces, it can keep oil and gas. And then this is another example. This is, again, a picture I borrowed. It's not mine. But these are just showing core photos, just like the previous one I showed before. Sometimes the reservoirs can get really what we call indurated, and they are not so, in terms of pore spaces, you don't see a lot of it. Sometimes they are fractured, like you're seeing on the one on the left. And these are all different things we do to characterize the subsurface. We go from the surface, we look at the cores, and we try to integrate what we will learn to better understand the subsurface. And that helps us in our estimating how much of oil or gas we have in whatever subsurface accumulation that there is. Okay. So these are also other elements that I just thought to put this together. So as subsurface scientists and engineers, what we also do is we don't only think about the rock in terms of, okay, this is a fun thing to look at as rock. No, we think in terms of depths. At what depth is this reservoir in question? What is the pressure? What is the temperature? How does that affect the oil and gas accumulation at that depth? I talked about oil window. How does it affect it? How can I recover the oil in that reservoir? And then the geoscientists will talk more about the lithology or rock type. What's the porosity? What's the permeability? What is the strength of the rock? Will it fracture at certain conditions? And then some other fun fellows called engineers, of course, also petrophysicists will now start talking about wettability. They are trying to understand how will the rock relate to fluid. Okay, they talk about wettability, effective permeability, relative permeability, and capillary pressure. These are all important for us to better understand this storage container called reservoir, and for us to better characterize whatever you have stored in the reservoir rock as hydrocarbon.